That's what this
because we don't
particular
know.
diff-
Yeah, we don't know V final, and we don't know T. Did it give us a time for how long it took him to hit the?
No. Oh wait, it did 2.9 seconds. Sorry.
There we go. 2.9 seconds.
Yeah, 2.9.
Okay.
That's helpful.
Yep. So now we can use, we have two options. We can either use this equation, or we can use this equation, solve for V final, and then use this equation. So I like to use the single step approach versus the
I agree.
multiple step approach. So let's just plug everything into this top equation here and work through it algebraically. So we can say y equals y naught. Oh no, y was 0. Y naught is our variable. Plus v naught times t, which was just 0. Plus 1/2 times our acceleration, which is negative 9.81. Times our time interval squared. Wrong, I'm getting 42.7 meters,
Yeah, that's what I got.
which isn't like necessarily a huge number, but that's a pretty high cliff to jump off of.
It doesn't matter if it's positive or negative.
It doesn't,
Because
but since we determined that down was our negative direction because we called acceleration negative,
yeah.
this would need to be the positive direction. So if this is 0, this would need to be something above 0. But it all depends on how you set up your coordinate system. So 42.7 meters. That's right. Was it 2.9 seconds or 2.95 seconds?
It was 2.9.
Oh, I think I just thought that S was a 5. So that changes it a little bit. 2.9 squared.
Still, yeah, 41.25.
Yep. So that should be the answer to part A.
Okay, and part B is how is the X? How far out?
So in the X direction, we know that his original velocity is maintained throughout his entire trajectory. So all we're looking for is how far or how much ground he was able to cover in that 2.9 seconds that he was in the air for. So we can use this equation, x equals x naught plus v naught t plus 1/2 a t squared. And what do we know about acceleration in the x dimension? What does it equal?
Whatever your initial velocity was.
The acceleration.
Oh.
Is there anything that's speeding him up or slowing him down
No.
in the x direction?
Uh-uh.
So a equals 0, which is nice, because 0 times these things is just going to be 0. So that whole term just goes away. X naught we called 0, so that whole term goes away. And so we're left with just a really simple equation. X equals our velocity times our time. So all we have to do is 2.4 meters per second times 2.9 seconds.
Say that again, which one would we do? The 2.95 times?
Yeah, so we do V naught in the x direction, which is 2.4
Okay.
meters per second, times time,
Okay.
2.9 seconds. So what does that give us? 8-ish or something? 2.4 2.4 times 2.9, just under 7. 6.96 meters.
Oh. I was expecting that distance to be farther.
Yeah, because the way that we had it drawn, right, it looked like his x was just as big as his y, but I mean, that's just,
Especially if he's going down.
So for my problem, on here, it's pretty similar. It says a baseball is thrown horizontally off a cliff with a speed of 7 meters per second. So how
Mhm.
would that change?
That's just changing the numbers.
Just
I
the
think.
numbers, right? So
what
I
is the
would-
horizontal distance to the nearest 10th? Yeah, so all it's gonna be is, for you, it's the same exact equation, x equals v naught times t, they gave you
Okay.
v naught.
So it'd be 7 times 7.3,
Mhm.
at least for this one.
For
the-
part 7.
For part 7, are you sure? What is the horizontal distance? So isn't that wanting x?
Yeah, that's what this is, x
Oh,
equals v naught times t.
v naught times t. Oh. And then for this next one, it wants how far it has fallen. How would I change those numbers up there? Would it just be,
So that would be just a y problem. So we've got a baseball, and it doesn't really matter, x and y are independent of each other. So just to simplify that question, and it's asking an 8, we'll just think of a baseball just falling straight down. In
Okay.
reality, we know that it's, falling to the right as it's falling down, so it's got like a curved path. That doesn't matter, it doesn't affect how fast it falls.
okay,
So we'll just have, here's the baseball when it's dropped, here's the baseball when it hits the ground. So we know that we've got y naught, b naught, and t naught. And then down here, we've got y final, v final, and t final. So y naught is what we're looking for. V naught, we know is 0 meters per second. Because like we talked about earlier, it takes an instant for gravity to start working on it and giving it velocity in the downward direction. Initially it's just 0, unless it's thrown up. If it's just thrown horizontally or if it's just dropped, then it's 0 initially. T naught we'll call 0 seconds. Down here we'll call y 0 meters, since this is the ground. We usually think of the ground as our 0 meter mark. V we don't know, and T we know is 7.9, is that what it said?
7.3, and we do know the 7 meters per second.
That's horizontal though,
Oh, okay,
so that's just the x direction.
okay.
So just like with this question, our V x naught was 2.4, but that didn't affect our V y naught, it was still 0. Does that make sense what I'm saying? So 7.3 seconds. Cool. So we know some things, we don't know some things. We can go back and look at our kinematic equations and ask ourselves which one is going to be most helpful. If we look at that second one, we might say to ourselves, well, we don't know V, we do know V naught, we know acceleration is negative 9.81 meters per second squared, and we know time is 7.3. But, so that would allow us to solve for V, but that's not what the question's asking for, so there might be a better equation to use. Because we want to look at one that has y involved in it. So if we look at that top one, we say, okay, we know y, we're looking for y naught, we know v naught, we know t, we know acceleration, and we know t again. So that one's a great one.
Okay,
Yeah, so the first one.
Yep, the very first one. So we can say y equals 0 plus 0, because v naught times anything is going to be 0, since v naught is 0, plus 1/2 times acceleration, which is negative 9.81, times our time, which is 7.3 squared. So 7.3 squared times 9.81 divided 2. So we end up with negative 261 meters. Oh shoot, I set that up wrong. So this was 0, and this was our variable. Which doesn't change anything except for the fact that now instead of it being a negative number, it's a positive number.
Okay.
Which is what we'd expect, since this is 0, and we're calling this our positive direction. So we can say y naught equals 261.39.4, or however many sig figs it was.